In February 2023, one of the most devastating catastrophes in modern history struck Turkey and Syria, a 7.8 magnitude earthquake that resulted in widespread destruction and the loss of over 52,000 lives. This tragedy raises a pressing question. Why is humanity still unable to predict such disasters? Scientists have long searched for earthquake patterns, yet even when they identify potential indicators, they struggle to explain them fully. A mysterious phenomenon discovered in 1961 by geophysicist John Oliver might hold a clue. He observed strange vibrations in Earth's crust occurring every 26 seconds, akin to a deep planetary pulse. Could this phenomenon be linked to catastrophic earthquakes like the one in Turkey? If so, could understanding it help us predict future disasters? Initially, Oliver's discovery was largely ignored because it fell under the category of microseisms, low-frequency vibrations ranging from 10 to 50 microhertz, far below human hearing levels. These fluctuations seemed too faint to pose any threat, and thus, scientists did not prioritize their study. However, in 1980, geologist Gary Holcomb revisited Oliver's work and found that these vibrations intensified before storms. His findings were overlooked until the same year, when a magnitude 7 earthquake struck California, causing massive destruction. Yet, despite the renewed interest in seismic activity, the 26-second vibrations were again dismissed as insignificant. Decades later, in the mid-2000s, graduate student Gregory Benson from the University of Colorado at Boulder stumbled upon Holcomb's research and decided to re-examine the data. His investigation confirmed the existence of the strange vibrations and identified their approximate epicenter in the Gulf of Guinea, off the western coast of Africa. However, skepticism remained among his peers, who initially suspected equipment malfunctions. When those were ruled out, researchers sought alternative explanations, suggesting that the vibrations were merely background seismic noise. Yet, unlike the chaotic nature of standard seismic activity, these pulses followed a precise 26-second cycle. Further research in 2011 by graduate student Garrett Euler pinpointed a more specific location, the Bight of Bonny in the Gulf of Guinea. For years, this was believed to be the sole epicenter of these mysterious vibrations, until in May 2018, a second epicenter was discovered near Mayotte in the Indian Ocean. Following this discovery, researchers sent the research vessel Marion Dufresne to monitor seismic activity in the region. Shortly after, over 1,800 earthquakes with magnitudes above 3.5 occurred near the site, leading scientists to suspect a connection between the 26-second pulses and major seismic events. At a 2013 conference of the Seismological Society of America, Euler proposed that these vibrations could result from ocean tides. When waves repeatedly strike the continental shelf, the pressure deforms the seabed, producing seismic impulses that resonate like a ringing bell. During storms, this effect is amplified by reverberations, as waves reflect and reinforce each other. The Gulf of Guinea's protruding continental shelf makes it an ideal location for this phenomenon. However, doubts persist, as similar continental shelf interactions occur worldwide without producing identical vibrations. An alternative theory emerged in 2011, when researchers from China's Institute of Geodesy and Geophysics, led by Yingjie Shao, proposed that the vibrations stem from volcanic activity. Both African epicenters of microseisms are near active underwater volcanoes, reinforcing the idea that magma movement might be the culprit. Supporting this, in 2019, a team from the Institut de Physique du Globe de Paris discovered an active underwater volcano near Mayotte, potentially explaining the rhythmic pulses. The link between seismic activity and volcanic eruptions is well documented. The 2021 eruption of the Cumbre Vieja volcano on La Palma, Spain, demonstrated how accumulated magma can create new vents and trigger destructive events. The eruption covered over 10 square kilometers in lava, destroying more than 3,000 buildings and causing severe health hazards due to toxic volcanic ash. Beyond geological explanations, some researchers are considering cosmic influences. Celestial bodies such as Jupiter exert gravitational forces that cause intense seismic activity on its moon, Io. Could similar forces impact Earth? In September 2021, just 12 days before the Cumbre Vieja eruption, an earthquake in Acapulco, Mexico, produced eerie red and blue lights in the sky, an unexplained phenomenon linked to the piezoelectric effect. Some scientists speculate that solar flares, which emit vast amounts of energy, could trigger earthquakes by charging quartz-rich rocks in Earth's crust, making them vibrate and leading to instability. A study published in Scientific Reports in July 2020 supports this theory, showing that increased solar activity often precedes earthquakes of magnitude 5.6 or higher. Additionally, research led by Giuseppe De Natale from Italy's National Institute of Geophysics and Volcanology found a strong correlation between solar emissions and the locations of the 26-second vibrations. Despite these intriguing findings, no definitive link has been established between these microseisms and earthquake prediction. Attempts to forecast seismic disasters using celestial alignments remain controversial. While Dutch researcher Frank Hugebeets gained attention for predicting the Turkish earthquake 3 days in advance, experts argue that his forecasts are too broad to be scientifically reliable. With a predicted wave of powerful earthquakes expected by 2032, scientists remain committed to unraveling these mysteries. Perhaps intensified monitoring of these microseisms will offer crucial insights before the next catastrophe strikes. Interestingly, during the COVID-19 pandemic in 2020, seismic activity decreased by nearly a third, suggesting that human activity may also play a role in Earth's seismic stability. The search for answers continues. Will we unlock the secret of Earth's 26-second pulse in time to prevent future disasters? Only time will tell.